Welcome back, everybody. We're going to be doing lesson 11 today, which is all about finding the equation of a line. So in the past couple lessons, we were graphing lines and plotting points on graphs, but now we're actually going to go the other way and find equations of lines. When we're either going to be given slopes and intercepts, we're going to be given points, or we're going to be given other types of descriptions, such as being parallel or perpendicular, and we're going to put all that together to find the actual equation of lines. So the application we're building up to here, the city miles per gallon X and the highway miles per gallon Y of two cars are given by the points 1620 and 4050, where if it's X and Y for both of these coordinates, then the 16 and the 40 are going to represent the city miles per gallons, and the 20 and the 50 are going to represent the highway miles per gallons. We're going to find a linear equation in slope-intercept form that models the relationship between city miles per gallon and highway miles per gallon. So we will come back to this at the end, but that's what we're working up to. We'll be able to find an equation that will actually relate the city and highway miles per gallon for us. All right, so first thing, we want to find an equation of a line given the slope and the y-intercept. This is by far the easiest section of these notes, okay, where slope-intercept form is going to make this almost trivial for us, because when we look at slope-intercept form up here at the top, y equals mx plus b, we only have two things we need to plug in. We need m, which is the slope, and b, which is the y-intercept. So if we're given slope and y-intercept, we don't really have to do anything except write the equation. Okay? It says, number one here, find the equation of a line in slope-intercept form with a slope of -3/4, so that's our m, and a y-intercept of 6, so that's our b. So literally all we have to do here is plug in those two numbers to the formula. Y equals -3/4x plus 6. Nothing else to it. Okay, number two, I made the numbers really scary just to make it seem harder, but it's just as easy. It says find the equation of a line in slope-intercept form with a slope of -993/1774, that is our m, and a y-intercept of -647/22,334, that's our b. Even though these numbers are horrendous looking, we don't have to do anything with them. All we do is write the m in front, where all I did was copy down what m is, put an x next to it, and then write down what b is, -647/22,334. So I did absolutely nothing with those two things. In both cases, I'm just taking the m, plugging it in. So in the second one, taking the m, plugging it in, and then taking the b and plugging it in. Taking the b, plugging it in. Okay, so no work to actually be done in this case, by far the easiest case. All right, let's take it up a notch. We're going to find the equation of a line given the slope and a point. So number three says find the equation of a line in slope-intercept form. Remember, we're going to be using that the whole time, y equals mx plus b, that has a slope of 4 and passes through the point 3, 15. All right, so we have a slope and we have a point. So what we're going to do is first plug in our slope right here. So this 4 is m. So I'm going to write the equation y equals 4x plus b, where I plugged in my m. But now the point represents coordinates on the graph. Okay, so this 315 is x comma y, where I can plug in the 3 for this x and the 15 for this y over here. So plugging in those two numbers, I get 15 is equal to 4 multiplied by 3 plus b. And now I can just go ahead and solve for b in this equation. So 4 times 3 is 12. If I subtract the 12 from both sides, I get that 3 is equal to b, because again, I subtracted the 4 times 3 from both sides. And if 3 is equal to b, now I can write the actual equation of this line. Okay, so now I can take my b and restart and just say that y is equal to 4x plus 3, where the 3 I just found is what goes into my formula over here, and I had the slope of 4 from the very beginning. All right, so overall my answer is just 4x plus 3. All right, next one. Now we have a slope of -7/5, and it's passing through the point 2, 2. Nothing about our process is going to change. I'm going to start with this slope right here that's given to me and write the equation y equals -7/5x plus b. where I'm writing plus b because I don't know what b is yet. But I have this coordinate 2, 2, which is x, y again. So I'll replace both the x and the y with 2. And then I'm going to be able to solve this equation for b. So now I'm going to have to work a little bit harder to get what the b value is because we have fractions involved. So on the left, I just have 2. And then negative 7 over 5 times 2 is negative 14 over 5. Now we're going to add that to both sides. So on the left, I'm going to do a little scratch work here, because when I add 14 over 5 to both sides of this equation, I don't want to add 2 plus 14 over 5 in my head, so I'm just going to do it on the side over here. 2 plus 14 over 5. If I find a common denominator, 2 is actually 10 over 5. So putting together 10 over 5 and 14 over 5, we end up with 24 over 5. So now in my equation, I'll write 24 over 5 is equal to b. And now I can go ahead and write my answer, that y is equal to the negative 7 over 5 we already had, multiplied by x, and then plus that y-intercept, that b value we just found. So in total, y equals negative 7 over 5x plus 24 over 5. All right, now we're going to add one more layer to this. Okay, so we're still using slope-intercept form, but now it says that b, the y-intercept, misspoke there. We're still using slope-intercept form, but now we're not going to be given the slope. Instead, we're going to be given points, and we're going to have to find out what the slope is based on those points. So for number 5 here, it says, find the equation of a line in slope-intercept form that has an x-intercept of 1 and a y-intercept of 6. So an x-intercept of 1, that is the coordinate 1, 0, and a y-intercept of 6 is the coordinate 0, 6. Okay, because y-intercept means x is 0, x-intercept means y is 0. Using these 2 points, I can go ahead and calculate the slope. So m is going to be equal to, it doesn't matter which point is which, but I need to label them as x1, y1 and x2, y2. That way I can use the slope formula. So then I'm going to do y2 minus y1, which is going to be 0 minus 6, over x2 minus x1, which is 1 minus 0. This is going to give me negative 6 over 1, which is just negative 6. All right, so now I have my slope, and I actually already have my y-intercept, which is the 6 that we were given in the original problem. So I can go ahead and now write my answer as y equals negative 6x plus 6, where that second 6 right here, this y-intercept, came from the fact that we were given the y-intercept in the original problem. It's not always that easy to get the y-intercept. Sometimes we have to solve for that b value the way we did on the previous slide. All right, and I do apologize. This bullet point up here, where I say given x1 and y1, we can substitute these values in. This should have been on the last slide, okay, because we were already using that on the previous slide. So I don't know how I ended up putting that one in the wrong spot. That is shame on me. All right, though, number 6. Find the equation of a line in slope-intercept form that passes through the points negative 4, 5, and 1, 1. So here we don't have a y-intercept. We're just going to go straight to finding slope, where m is going to be equal to, and again, it doesn't matter which point is which. You just need to label one as x1, y1, and the other as x2, y2. That way you can use the formula. Does not matter which one's which, though. So here I do y2 is 5 and y1 is 1. So I'm going to do 5 minus 1. Divide that by x2 minus x1, which is negative 4 minus 1. This simplifies to be 4 over negative 5. And so my slope is just negative 5 over 4. Oops, said that backwards. Is negative 4 over 5. There we go. So now we're going to set up y equals negative 4 over 5x plus b, where I don't know this b value yet. And now I have to make a decision because I have 2 coordinates I could plug in for x and y, and I can use either one and I'll get the same b value either way. So I always just choose the point that's easier to plug in, which if you look at the coordinate in the top, negative 4, 5, that's not going to be that beautiful to plug in because it's going to make that negative 4/5 even bigger. So instead, I'm going to plug in the coordinate on the left, which is this 1, 1, for this x and y right here. When I plug in 1, 1 for x and y, I'll get a 1 there and a 1 here. So I'm going to get 1 equals negative 4/5 times 1 plus b. In order to solve this, I'm going to add the 4/5 to both sides. On the left side, when I add 4/5 to 1, 1 is just 5 over 5. So when I add 4 over 5 to 5 over 5, I'm going to get 9 over 5. And this is going to be equal to my b value because everything else on the right side just canceled out. And so now we can write our answer, which is that y is equal to the slope of negative 4 over 5 times x plus the 9 over 5, which represents our b value. All right, now moving on to parallel and perpendicular lines. Parallel lines are lines that have the same slope but different y-intercepts. So if we draw ourselves a little coordinate grid over here, okay, if I draw a line that looks just like this, and I want to make a parallel line, what I'm going to do on the iPad is literally click it and click duplicate. But notice when I duplicated it, it's going in the exact same direction as the previous one. And so when you hit that duplicate button on the iPad, it actually makes parallel lines for you. But notice what's true about them. They have the same slope, so they're both going in this exact same direction, but they have different y-intercepts. One y-intercept is up high, the other was down low in this case. If they had the same y-intercept, so if I took this line and gave it the same y-intercept as this line, they would actually just be the exact same line. So parallel lines are lines, same slope, different y-intercepts. Perpendicular lines, on the other hand, are the xy axis as a perfect example. Notice that they make a plus sign when they cross. Okay, so they form, if you look at our bullet points, they form a right angle where they cross. So you can see this little right angle box on all of these sides, all of these angles. And perpendicular lines have slopes that are negative reciprocals of each other. Okay, so if the slope of line A is m over a, then the slope of line B is going to be negative 1 over m sub a. So if slope of line A is m sub a, so that's just the first slope, then the slope of line B is negative 1 over m sub a. This is going to look really easy in practice, okay? The phrase negative reciprocal is actually easier to understand than this fraction is. Negative just means change the sign. So if it was positive, make it negative. If it was already negative, make it positive. And then reciprocal means to flip the fraction upside down. Okay, so we already know how to do a negative reciprocal without thinking of this fraction over here. All right, so let's do 7. It says the slope of line A is negative 19. Find the slope of a line parallel to line A. So if it's parallel to line A, that means it has the same slope. And so m is going to equal also negative 19, where I did not change anything about it. It's the exact same slope. If we want to find the slope of a line that is perpendicular to line A, then we're going to do negative 1 divided by negative 19. And this is going to simplify to be positive 1 over 19. Where notice all that actually happens when I do that is the negative sign that was in front of it goes away. And instead of 19 over 1, now it's 1 over 19. Okay, so all we do is the negative reciprocal. When you have a fraction to start, I feel like this actually looks even easier. So for number 8, the slope of line A is negative 17 over 4. If we want a parallel line to line A, its slope will also be negative 17 over 4, where we didn't change anything. But if we want the slope of a line that's perpendicular to line A, then we're going to take negative 17 over 4, and we're going to put a negative 1 on top and negative 17 over 4 on bottom. I recommend, though, that you don't actually think of it this way, okay? Because thinking of it that way makes it look way more confusing than it actually is. Okay, when we want to find a negative reciprocal of something, all you need to do is change the sign. So instead of a negative 17 over 4, I'm going to make it positive, and then flip it over. So positive 4 over 7, where all I did was flip this upside down to get the 4 over 17. Okay, so in the end, my negative reciprocal, my perpendicular slope, is positive 4 over 17. All right, now we're going to put that into practice. So number 9 says to find an equation of a line parallel to a given line. So we're going to find the equation of a line that has the same y-intercept as this line, this first one we're given here, and is parallel to the second line. So what we need to do is we need to find the b value of the first line, and we need to find the slope of the second line. Okay, so from the red line, we need its slope. That way we can use that slope for our new equation. And from the first line, we need the b value, because that represents the y-intercept. That way we can find our new equation with the new y-intercept. So what I'm going to do with both of these lines is write them in slope-intercept form. So for the blue line, I'm going to take y minus 9x plus 7 equals 0. And I'm going to move the 9x and the 7 to the other side to get y equals positive 9x minus 7. When I do that, you can see the negative 7 is the b value. Okay, so b equals negative 7 here. That b value is going to go into the equation of my new line. So my new line's equation is going to be y equals mx plus b, where I already know that the b value is going to be the negative 7 that I just found. So now I just need to find out what is the x value, sorry, not the x value, but what is the m value. Down here, this m, I need to know that m so I can put it next to this x. So we're going to use the red line to figure out what that m is. So we'll take 2x minus 7y equals 12. And we're going to put this into slope-intercept form so we can see what the slope is. So in order to do that, a couple more steps to do this one than the other one. I'm going to go ahead and subtract 2x from both sides. So I have negative 7y equals, and on the right side, it says 12 minus 2x, but I'm going to write it as negative 2x plus 12, okay, because it's better to have the x on the left. And then I'm going to divide everything here by a negative 7. When I simplify this, I get y on the left is equal to negative 2 over negative 7 is positive 2 over 7, and 12 over negative 7 is negative 12 over 7. Okay, so just make sure you're careful with your negative signs there, seeing what cancels. And from this equation, we can see that the 2 over 7 is our m. All right, so we're going to take that m, we're going to plug it into our equation at the bottom of the screen, and the actual answer to our question is the line y equals 2 over 7x minus 7, where the 2 over 7 is the same slope as the original red line, so that means it's parallel to that red line. And the negative 7 is the y-intercept of the blue line, so it has the same y-intercept as that blue line. All right, one more question in here. Now we're just going to do the same thing, but now it'll be perpendicular. And instead of being given two different lines, now we're given a line and a point. So it says write an equation for a line perpendicular to y equals 2x minus 2. And passing through the point 4, 1, where this will be an x, y that we can plug in. All right, so first we just got to deal with this part about it being perpendicular. Y equals 2x minus 2 has a slope of 2. So if we want a perpendicular slope, okay, so I'll call this MP for the perpendicular slope. This is going to be equal to the negative reciprocal of 2, which is negative 1/2. All right, so negative reciprocal, we flip it upside down and we throw a negative sign on it. All right, and then all we need to do is now write our equation, which is going to look like y equals negative 1/2 x plus b, where I took my negative 1/2 from right here and plugged it in. And we're going to use the coordinates 4, 1, the x and y from the right side of the screen, plug those in. So we're going to get y equals, let me write the equal sign in block, y equals negative 1/2 multiplied by 4 plus b. When we simplify negative 1/2 plus 4, or times 4, that's just going to equal negative 2. So we have 1 equals negative 2 plus b. If I add 2 to both sides, I get that our b value is 3. And so I can go ahead and conclude now that the equation of the line I want is y equals negative 1/2 x plus 3. Where that 3 I just got was the 3 from setting, or from finding this b value right here. Okay, so we have our slope from earlier, and we have our b value of 3 right there. All right, and now we just got to do the application question, then we're all done. So we're going to go back to the top of the screen. Okay, and we are going to now relate the city miles per gallon and highway miles per gallon of two cars. So we were given two coordinates, 1620 and 4050. We want to find a linear equation that models this relationship. So we want to find a line that goes through these 2 points. So if I label these as x1, y1 and x2, y2, I can go ahead and calculate slope using those 2 points. Where on top I have 50 minus 20. On bottom I have 40 minus 16. This simplifies to be 30 over 24. And if we simplify that even further, we can keep going because this is reducible. So 30 and 24 are both divisible by 2, so I can go down to 15 over 12. And you might be looking at that thinking, wait, can't we go even further? You're right. 15 and 12 are both divisible by 3, so we can write this as 5 over 4. All right, if you didn't like that I did a string of simplification here, you can always do that in one step, right? So from the beginning, we could have gone straight to the fact that top and bottom of this, 30 over 24, are divisible by 6. So 30 divided by 6 is 5, 24 divided by 6 is 4, and we can get there even faster. I always like to show you multiple ways because, quite honestly, sometimes it's more work to find the GCF than it is to just do the number that you immediately think of. So if I know top and bottom are both even numbers, usually I'll factor a 2 out right away because then it makes it easier to see what else might be factors. But that's all personal preference. You can also always do scratch work on the side as well. Okay, so now we have our slope. So now we're going to write our equation with this slope plugged in. So y equals 5 over 4x plus b. I'm going to go ahead and write that 5 over 4 in blue to match what was on the side. All right, and then now we can plug in either of our coordinates to find out what this b value is. So I'm going to go ahead and use the 16, 20, just because those numbers are smaller than the 40 over 50, but it does not matter which one you choose. So I'm going to plug in 20 for y and 16 for x. So we're going to have 20 equals 5 over 4 times 16 plus b. 5 over 4 times 16 is a nice convenient fraction because 16 is divisible by 4. So 5 fourths times 20, or 5 fourths times 16 is 20. So we get that 20 is equal to 20 plus b. If I subtract 20 from both sides, I get that b is actually 0, which is convenient because that means we don't even have to write a b value in our equation. So we can go ahead and just finish this off and say that y is equal to 5 over 4x. No b value on there. We don't even have to write it. And so what this tells us is that if your city miles per gallon is x, then you multiply it by 5 over 4, and that'll give you your highway miles per gallon. Now, if you're wondering if this is accurate at all, I did use the approximate miles per gallons from 2 cars that I've had in my lifetime. So my first car only got about 16 in the city and 20 on the highway, and my second car was about 40 in the city and 50 on the highway. So I'm not saying that this holds true for all cars, because it definitely does not, but just for the cars I've driven, there is actually a relationship where you multiply the city miles per gallon times 5 over 4, and you get the highway miles per gallon. All right, I hope you guys enjoyed lesson 11, and I hope you recognize that this lesson was much more mathy than other lessons we've had, and that's going to start to be more and more true the farther we go in this class. We are solving things now, okay? So you need to be comfortable solving equations from here on out because we're going to be doing it all the time, okay? We're going to be working with numbers, we're going to be adding, subtracting from both sides, multiplying and dividing. It's just the way the cookie's going to crumble. And so stay with me, ask questions when you are struggling, and I am excited to see you guys in class next time.